Well, welcome back, everybody. I'm going to give everyone about 10 more seconds just to make sure if we got every straggler, switching over to our next session here before we go ahead and get started. But I'm glad to go ahead and kind of start with our introduction. So, for this session, we are going to be joined by Pani Singh, and he's an optimization consultant within the paper and pulp industry. So hopefully we're going to gain some really great insight into the industry.
My name is Pami Singh with Singh Process Optimization Consulting, and spent many years in the industry working with operating people and technical people. And my talk today will be trying to leverage dataPARC tools for continuous improvement. So in the whole world of continuous improvement, you'll hear a lot of words like Lean, Six Sigma, root cause analysis, variation, replication, all this stuff. What does it all mean? And CI tools are pretty powerful tools. And what I'm going to try and figure out how I use the dataPARC tools in conjunction with the CI tools to help us enjoy making the improvements in a much faster way. Done it both ways, and once you start using some of the embedded statistics that are built into dataPARC, you can get there a lot faster. So continuous improvement, I call it the process control approach. You almost have to first stabilize the process. Once you stabilize the process, only then can you start making improvements that are going to be meaningful. And then the last part that's most important is how do you sustain the gains that you make. So before you start anything, you always want to understand what is it, what are the levers and what is it that I'm trying to do. And so you identify the gaps and then you figure out how to close those gaps. And that's in the section of the improvement section, the technical process improvement section. Then when you're starting to try and sustain the gains, we typically always think about, if you use both administrative and process control tools, you can sustain that a lot further in time. If you just use administrative controls, then you tend to still make gains, but you can start losing ground over time. So here's one area that I wanted to first start with, what the mental model I have for what continuous improvement really does. First of all, you have the foundation of any house, and safety, training, standard work, management of change, things like that are critical in any kind of process that you're going to work on. I mean, that's just going to be fundamental things that you need to do. Think about what you're trying to do is get a lot of employee engagement. You want to get shareholder value and ultimately customer employee satisfaction. In order to do that, this is the section, this is the area where we ramp up how we do improvement. And I'm going to talk about three areas. First, you identify the gap and how are you going to close the gap. Then I'm going to talk about control/automation, and then getting examples of root cause analysis and deviation detection. But what the most important thing that I want to basically assess here is that there's an 80-20 rule that I used that means that 20% of the effort it took to get 80% of the benefit. And sometimes you really need to spend a lot more effort to try and get that last 20%. And some of the Lean Six Sigma, Blitz, Kaizen events that with massive black belts involved are critical for success. And the reason you do those is, you're making a fundamental shift. You're trying to get your customers a new tool, new specifications that they need, whatever the needs are. It takes a lot more effort to get that, and you want to have a systematic process to do that. And again, dataPARC tools are very critical. I'll just talk about root cause analysis and deviation detection as part of that. So here's an example of a screen that we developed for operating personnel. And Again, the power of the trending, the power of the calculation engine, and the ease of use, both speed and flexibility, are absolutely critical. You want the key performance indicators, you want the online visibility, and you want a feedback and monetization process. So here's where what we think about is, first you identify the gap. The gap can be an industry-based best practice, or you found a time in deviation from a time that things were running very well to where it is right now. So what we look for is, here's a screen where 4 or 5 items, speed, basic, furnish, and things like that, chemicals and steam, all these are going to impact your monetization or your benefit side. So red means that you're losing money, green means you're making money. These red bars and green bars are, when it's green, that means somebody's actually entered a reason for the deviation. Reason I've highlighted this area, so this is the chemical area, and then this is all the chemicals that are impacting that. And you can see in the chemical it's green, all these things are green. You'd have a similar one for speed and basis weight and so forth. So the very clear interaction with the operators to try and close the gap and then give them a tool. And I've even had operators actually take screenshots and at the end of their shift and sent me, hey, we made X amount of money this shift. A lot of pride in that and a lot of engagement in that. So the next part that is critical is, if you can, once you make your gain, how do you sustain that gain? So that's what I'm going to talk about next, is the automation and control. So again, how do you sustain the gains? And I've talked about process control and automation. How do you institutionalize your standard operating procedures? Through control. That is critical. In the past, I've never talked about training. With operators and operating personnel, it's more a roundtable. It's more an interactive process where knowledge is shared and feedback is taken, and you use the dataPARC tools live in real time to go address some of the concerns that people might be having, so that where they may not have time in their own operating areas to actually dig deep into a problem, you can do that in this roundtable session. And the control piece that is so critical for sustaining the gains is only going to be as good as the sensors and instrumentation that we use. And for sensor health and instrumentation health, dataPARC has loop health monitoring tools, and they can flag the needs for particular loops that need to be worked on and so forth. Where I'm going to focus more on today is the soft sensors. Soft sensors are done through modeling of the process. And this modeling software is very, very well integrated in dataPARC, and it's easy to use. The critical part of doing this is, let's say you've got lab analysis that are coming back, 2 to 4 hours or even longer. And you want to make sure that your model is predicting in between those time periods to see if things are significantly varying. If they are, then you can actually go ask the operators to get another test for you, or you can just go ahead and identify the deviation or get some help and say why might something be going on. The other part is, a lot of times you have very expensive sensors and tools, like maybe costing $200,000 to $500,000 for a predictive tool, or a testing tool like a kappa analyzer or something like that. Well, what we've found is that we have used process modeling to predict what the analyzer should be doing, and then we trend the two together. When they start deviating, an operator can go and actually go get another test, and not from the analyzer itself, but go do a lab test and verify what it is. And we can then, the operator can actually use the predictive sensor to be his tool until whatever deviations are happening in the actual sensor can be fixed. And that's worked fairly well. When I talk about administrative controls, and those are basically procedures and changes and expectations that are communicated. And if you only do that, you're not going to make much gain. But if you do that in conjunction with process control, tools like logbook and even smart alarming tools, two-way communication tools that dataPARC has built in very well, can really help you sustain the gains that you try and make. Now I'm going to talk about building a sensor. So first you do is you get all the tags that you can that might be impacting or pertinent to that sensor. Right click, hit Park model, then you say I want to create a PLS model. PLS model comes up, and initially you say, wow, I've got a 0.9 R squared, that's awesome. But you also know that there are some variables that have flows that are less than 0. So what you do is you go ahead and filter that data, put the zeros in, and then we know there's downtime, and I want to eliminate that downtime. So I go back to my downtime tag and say, okay, if you're down, I want you eliminated. And so then what you do is you make sure you come back to this area here where the calculation engine is, hit that, it recalculates it for you and eliminates those points that are outside. You look pretty good. You come back and you look at any variable that is now not in play. When it's not in play, you come back and you remove these unused tags, and what that does is redoes the model for you. And it changes the R squared a little bit, but more than else, it's still got variables that are outside the elliptical screen on the right. So you clean that up. Once you clean it up a couple of times, you're basically ready to go with your model. And so I'm going to do that one more time. Then I'm going to come back and look at my model itself and say, okay, I got a 0.95 R squared. My D mod X looks pretty good. I'm going to go ahead and look at the model parameters and see what variables and the importance of those variables are. And you can go through that, and the least important variable has still got a 1.4% contribution. And then you look at the model coefficients and make sure that the signs on those models are realistic. And if they are, then you go save the model. So I'll do that next. Once you save the model, and you go put in the pertinent information, continue. Then what I want to do is go see how well did my model do compared to. So basically, at this point, you launch the predicted trend. So I had to make sure that basically you look at the two variables, the blue and the red color pen. The blue is the actual variable and the red is the model. This is for the time period when I made the model. I want to go forward in time and see how well is it predicting after I've made the model. And you can kind of see it's done pretty well. So I can test that out with a couple of other variables, make sure that they're behaving themselves. So with that, after the model is done, I want to go ahead and now look at the next section, which is root cause analysis and deviation detection. So root cause analysis, deviation detection, smart alarming. These three things kind of really are the crux of making sure that you're always sustaining the gains and your daily management is good. Most root cause analysis are done on maintenance type events, but it's critical that a multifunctional team do the root cause analysis both on the process and the maintenance side. You have to almost stay ahead of the potential failures, or else you're never going to get out of this rut. So what we found is that the ParkView tool, deviation detection, has been very, very important. At least towards the end of my career with major corporations, that was the area that I was going to focus in on most. And I'm going to give you an example of that. The last part of smart alarming is a very powerful configurable rules where you have deviations in real time the reasons for that deviation can be logged, and you can develop a database for that. And alerts of those deviations can be sent out through emails and text messages or whatever. Again, all that is early detection and minimize the events of failure. So I'm going to now show you a system that, we had a situation, with a real, where they were running a grade, product grade that is running really well now, but about 2 weeks ago, it didn't run as well. So what first we do is you go pull the grade tags and go last 20 days, come back and you go find the time period. It's grade 1051, and that was the time they said it didn't run as well, but they ran it just recently, and it actually ran pretty well. So what you find those 2 time periods, and then you go pull up the screen that has all the graphics and most of the tags that might be involved with that. And what you do is you go ahead and pull that data into your deviation detection tools. So again, you don't type any of this stuff in. You can drag and drop these from anywhere. And right now, and then you rank them. Critical part is you give it the start and end time, which we kind of get the data from the database, and for base data. And then you go give it the start and end time for the second period, and you go get the data. Again, you get the average and standard deviation of both periods, and then you start doing the comparisons. It's critical. You've got change, COV change, standard deviation change. There are other statistics as well to be done. We'll just focus on percent change, and we've set the percent to 10%, and we're just going to look for those variables that are deviating more than 10%. And pink is positive, and blue is negative deviations. So in this particular example, you can see that silica changed from 0.98 to 1.46, almost a 49% change. Well, what we want to do is kind of trend those and see how they look. So you get this highlighted, trend it, and you can see the 2 periods. The left is the period where it wasn't doing so well. The right is the period where it is doing well. And you can actually get a visual, very powerful. And what I have used this for, I mean, again, it's as good as you are going to be as an engineer or as an operating person. If you can envision how you want to compare data, how you want to manage with data, this tool is very powerful. And our only, I would say, the only thing that holds us back in using tools like this far more effectively is the horsepower that we have in our computing engines anymore. But the ease of use is exceptionally well. And I would encourage people that if you want to learn more about the modeling software, Richard Chinnis will be giving a training class on that next week. And if you want to learn more about the deviation detection tool, I think Neil is going to be giving a training class on that next week as well. So with that, if you have any questions, we'll do that. Thank you.
Excellent. Well, hi, Pami. How are you?
Good, thanks. How are you doing? Can you hear me okay?
I hear you great. Can you hear me?
Yes, I can. Thank you.
Excellent. Well, it sounds like you're an absolute dataPARC champion.
I've used it a lot, and it's made me very successful. It's made my companies that I've worked for very successful. So again, I think the key piece is ease of use and flexibility, and if you can envision it, it's probably got a way to do it. It's just going to be up to us to figure out how.
Absolutely. And is there anything that we've kind of talked about with version 7 or kind of our upcoming new additions to the product? Is there anything that kind of stands out to you that you're really excited to have added?
Well, yeah, I mean, a lot of that is the good thing about the people that work with these tools and the people that develop them, they keep track of all our needs, and then at some point or the other, they integrate that into the next version. And this next section is going to be very, very powerful. So yeah, I'm looking forward to it.
Well, excellent. That kind of wraps us up for today. So, I wanted to say thank you again so much for joining us, and we really appreciate everything you had to show us.
Thank you.
Excellent. Well, have a good one. All right. Well, now for everybody else, we will be starting our next session here in a few minutes, a couple minutes. So, 11:15, we're going to jump back into the added QA session that I mentioned earlier. So we're going to bring out Kevin Clark and Steve Lake. We're going to bring both of them back to kind of answer any general questions or anything, to talk more specifically about the product development vision that we've shared. So, again, head back to that home button, hit on that next session, and we'll see you there.